so let's take a look at what you just completed. Your spin diagrams for sulfur, hydrogen, selenium, and hafnium. And this is what all of yours should look like completely filled in. I was just trying to show you the important stuff here at the end so that you could double check. Obviously, these would all have the up half arrow and down half arrow. Excuse me. Again, a trick if you want to underline like your 3 dashes here and your 3 dashes here to represent your 3p orbitals, and then the 5 over here for your d's, and then here for your 7 f's. If that's something that helps you, then please do that. You're not allowed to skip orbitals. Okay, so if that helps you kind of keep track. And then notice for hafnium, you're ending on 5d, and there are only 2 electrons in there. Selenium has only 4 electrons in the 4p. Okay, so once you go ahead and check your work here, I'm going to show you a shorthand that is going to save you some time and keep you from drawing all those arrows. So I know hafnium is down here. I am going to show it up here just to kind of make it a little bit simpler for you. And I know I'm giving you one of the answers, but I just feel like that might be the easiest thing to do. So what we're going to do is we are going to take each one of our orbitals and we're going to write them down with their energy level, and then we are going to write the total number of electrons as a superscript. Okay, so for this orbital, it is filled, so I have 1s2. Here's my superscript, that's representing the electrons that are in that orbital. Then I have 2s2, representing the fact that my second energy level s orbital is filled with 2 electrons. Then I would have 2p6, because there would be a total of 6 electrons there. Then 3s2, because that would be filled. Then 3p, what am I going to write? 3p what? 3p6. Then 4s2. Then 3d, I have 5 orbitals, so, and they're all filled, so that's going to be 3d10. Then 4p6. 5s2. 4d10. 5p6. 6s2. 4f. Now remember there's 7 here, so 4f14. And then I'm ending with my 5d. And there are only 2 electrons there. So that's how you do this shorthand. So that's what you're going to be doing in this section of your paper. I'll show you 2 short ones from what you worked on again earlier. Excuse me, if we were to do hydrogen, we would just have 1s1. First energy level, s orbital, 1 electron there. If we were to do carbon, it would be 1s2, 2s2, and then 2p2, these 2 electrons. If we were to do, potassium, let's just do that one, and then I'll let you do yours. Let me see if potassium's on your paper. I'm not going to do another answer for you. Okay, so potassium, you have that down here. And actually, I can just write it in down here. So 1s2, because it's filled. 2s2, representing this guy. 2p6. Then 3s2. 3p6. 4s2. Whoops, nope, I lied. 4s1. And we would be done. So go ahead and again, you can do this right from looking at the periodic table and being aware of the table that I had you color in before Christmas, if I find it. being aware of this. And this is where, just until you get more comfortable, I might use the flip side of this that has the F actually embedded in the periodic table itself, so that you don't forget an F whenever you're working your way across. So this tool and your periodic table are what I would use as I work through these. Okay, so there's one more shorter one than that, but sometimes it gets confusing, so we're going to hold that off till tomorrow. Good luck, and have the sub call me with any questions from the school phone. Thanks.